Imagine an AI system. It's making a really critical decision. Maybe a medical diagnosis, could be a big financial trade, or even deciding if you get a loan. Now, picture asking the company behind it, okay, why? Why exactly did it make that call? What specific data did it look at? How much did each piece matter? What if the answer, even from giants like OpenAI, Google, Microsoft, is just, we can't actually tell you. That's not just a gap, is it? It feels more like a chasm when we talk about accountability. So today we're doing a deep dive into exactly this. AI accountability, the huge need for transparency, and a really profound new approach that claims it can crack this black box problem. And get this at the hardware level. We're looking at something called FIM technology from ThetaDriven. Our sources suggest it's a breakthrough discovery, basically saying semantic, meaning, the meaning of data, can directly be a memory address.
Right. And our mission today is to really get into these sources, to unpack what they're claiming. We're going to challenge, I think, our standard ideas about semantic indexing. And we'll explore how this concept they call SAPH, that semantic equals physical equals hardware, could actually give us hardware verified proof of why an AI did what it did. And look, this isn't just some technical curiosity. It's potentially a direct path to compliance, and maybe more importantly, a way to deal with the massive liability risks that come with AI right now.
Okay, let's unpack that core problem then. Current AI, mostly, it's a black box. You ask a vendor, prove what data your model used for this specific decision, and crickets, silence. They just can't. And the sources we looked at confirm this isn't about them being difficult, it's a fundamental technical thing. Even the biggest players, OpenAI, Google, Microsoft. The tech hasn't really allowed for that kind of proof. And for you listening, maybe you're a decision maker, a developer leading a business, the consequences of not being able to explain are already hitting, and hard. First off, customers leaving. Gartner reported, 40% customer loss after just one AI mistake or hallucination?
Staggering.
And it's not always the mistake itself, is it? It's that we can't tell you why. When a company says, we're looking into it, customers hear pretty accurately sometimes, we actually have no clue, and boom, trust is gone.
Vanished instantly.
Then you got the regulators. The hammer is coming down, or maybe it's already landed. The EU AI Act, it's active right now. We're talking potential fines, huge ones. 35 million for AI you can't explain.
And don't think that's just a Europe thing.
No way.
Yeah.
The NIST framework, that's coming Q2 2025 for the US. And you know it's going to be heavily influenced by what Europe does, that whole Brussels effect.
Absolutely. EU rules often end up setting the global standard, and you've got state-level action too.
Right, like California's SB 1001.
Yep.
Already on the books, demanding transparency. And finally, the legal stuff. Just imagine a discrimination lawsuit. Prove your AI didn't discriminate when it denied this loan.
Or a medical case. Prove you considered everything, all the symptoms, the drug interaction.
Exactly. And saying, our model had 94% confidence. Well, that just won't cut it with a jury, will it?
Not a chance. You need proof. Auditable, verifiable data lineage, not just probabilities. Which brings us right to the technical core of it. Why can't current AI systems just show their work, in a way that satisfies everyone, regulators, customers, judges? The problem, as our sources really dig into, is how they handle semantic meaning. The actual understanding of the data. Let's look at what pretty much everyone else does, the big names included. When they process meaning, it goes through several steps. Meaning hits a hash table first, then goes via pointer, then to a memory location, and then finally get to the data itself. It's like, 4 or more hops?
4 hops just to connect meaning to data.
Yeah, at least. And each hop adds overhead. You get cache misses, translation delays, and crucially, the hardware isn't optimized for the importance of that data. It doesn't know what matters most. So what these systems give you is meaningful proximity. Think LSI, knowledge graphs, vector databases like FIS or Pinecone, models like Word2Vec, BERT. They're great for saying, okay, cat is near dog in this abstract space, or diabetes connects to insulin. That makes sense. But, and this is the key point from our sources, proximity doesn't mean it was actually considered for a decision or how important it was. One source called it proximity chaos.
Proximity chaos. I like that. It's like my downloads folder. I know all my holiday photos are somewhere in there. They're all related to holidays, but finding the one specific picture I need right now, forget it.
Exactly. It's an organizational mess, but with a much higher stakes in AI.
Yeah, so for you, the person relying on this AI, that proximity chaos has got to be maddening. These tools find related stuff, sure, but they can't tell you which specific bit was used or why it mattered for that outcome. Proximity just isn't enough when the lawyers come knocking. Okay, so we've got the problem, the black box, the customer fallout, the fines, the lawsuits, and the technical reason. And this multi-hop proximity stuff just doesn't cut it for attribution. But what if the answer isn't more software layers trying to explain the mess? What if it's something deeper? At the hardware level, our sources point to this patent-pending discovery that might just flip the whole thing on its head.
Exactly. And that's where ThetaDriven comes in, according to these sources. They're claiming this discovery, FIM technology, completely changes the game. Their core idea is, well, it's almost shockingly simple. Semantic meaning equals the memory address.
Directly.
Yeah.
Not points to or is mapped to.
No equals. 0 hops. No translation layers, no hash tables, no pointers needed for that core link. The sources state it pretty bluntly. Heart disease isn't mapped to address, say, 0 by 7 FFF 8000. It is address 0 by 7 FFF 8000.
Wow. That is a fundamental shift.
It really is.
Yeah.
And that leads to this critical difference. FIM aims for meaningful position, not just proximity.
Meaningful position. Okay, what does that mean in practice?
It means position 1 in memory isn't just related data. It literally means this is the most important factor for this specific decision. Position 1000 is less important for this decision. So it's not just about things being vaguely connected. It tells you exactly what was used and its rank order of importance. They use something called a short rank algorithm to sort the data by importance, aligning the meaning directly with the physical memory spot.
So importance dictates the address?
Precisely. And the interesting thing is, this isn't some, wild new theory that breaks everything we know. It actually leans into basic computer science principles. Our sources point out its CS101 really sorted lists are way more efficient. They get 10 to 100 times fewer cache misses than jumping around randomly in memory.
Right. Random access kills performance. CPUs like things in order.
Exactly. CPU prefetchers need that sequential access. So when importance dictates the memory position via short rank, the most important stuff automatically clusters in the CPU cache. Always. It's just physics, spatial, and temporal locality. And this leads to huge performance boosts. The sources cite in gains of like 8.7 to 12.3 times faster, just by working with the hardware, not fighting it.
Okay, so it's faster and it encodes importance directly.
Right. And this leads to what they term the unity discovery. SPAH, Semantic A. Physical hardware. The sources are careful to call it a discovery, not an invention, like uncovering EMC card. They're saying they didn't create this link, they just revealed something that was always mathematically true, that semantic importance, physical memory layout, and hardware access patterns become literally the same thing if you organize the data by importance. It's a unification.
That's pretty profound. A unification of meaning, memory, and hardware. Okay, bring it back for us if this is true. If meaning is baked into the hardware location like that, what does it do for our ability to show the AI's work? How does it solve that core accountability problem?
It changes everything about showing your work. It goes from being this incredibly complex software challenge, maybe even impossible, to being a simple, verifiable hardware fact. When you have SAPH, the memory access pattern is the record of the work done. It's the proof.
And how do you see that pattern? How do you verify it?
Through standard hardware counters. Intel and AMD CPUs have these things called model-specific registers, or MSRs. They're built-in hardware logbooks. They record exactly what the CPU is doing, including memory access. Our sources even mention specific counter addresses, like 0 by 41P, 0500C5, 0 by 01A2. These registers track cache hits, misses, memory accesses at a hardware level, and the key thing, as the sources state very clearly, these counters cannot lie. They provide an immutable ground truth record from the hardware itself.
Or revert truth. Okay.
And this directly tackles that monster problem called combinatorial attribution. Think about medicine, maybe 68,000 different medical codes. The number of ways they could combine to influence a decision, it's like 10 to the power of 20,000 paths. Insane.
Yeah.
Impossible to trace with current AI.
Wait, you'd never unpick that.
But with FIM, the sources claim attribution becomes exact. The system can literally say positions 1, 47, and 203 were accessed for this decision. Full stop. Now, there's a key requirement here they call orthogonality. It basically means you need to keep independent concepts separate in memory. Like patient symptoms should be in a different dimension or area of memory than prescribed treatments.
So you don't mix apples and oranges when tracing the decision.
Exactly. You need that clean separation plus the meaningful position. You need both for attribution to work cleanly. Without both, you're back to chaos.
Got it. Orthogonality and meaningful position. And this hardware verification, it sounds like it directly answers those regulatory demands we talked about.
It seems to. The EU AI Act wants explainable decision paths, not just a confidence score from a black box. FIM seems designed to provide exactly that path via memory access.
And the NIST framework needing auditable data lineage.
Same thing. This hardware log is the lineage, arguably going deeper than just trusting the training data logs.
So for a medical case, you could actually show the system accessed the data related to that specific drug interaction.
That's the claim. You could point to the specific memory positions linked directly to that semantic meaning, and the hardware counters proving they were accessed.
And for finance, prove no insider data was used.
If that data lives at specific addresses, and those addresses weren't accessed according to the hardware log, you have your proof. It's hardware-level evidence, where, again, lies are impossible. Let's maybe connect this to some bigger picture stuff. Real-world situations where milliseconds cost millions, or where lawsuits can just destroy a company. Think high-frequency trading. Our sources paint a picture where detecting an anomaly currently might take, say, 6 milliseconds, which sounds fast,
That's
right?
incredibly fast.
But in HFT, that delay can mean $1 million lost, maybe more. With FIM, because the important data is already clustered in the cache thanks to SPH, detection could theoretically happen in under 1 microsecond.
A microsecond. That's 1,000 times faster.
Yes. You stop the loss before it cascades. And crucially, afterwards, you have the hardware log showing exactly which positions, which data points triggered the sell-off. That's your legal defense. Positions 1 through 50 were accessed, indicating condition X, triggering the pre-programmed sell. Verifiable.
Wow. Okay, that's stunning for HFT. The speed plus the proof. What about that medical diagnosis scenario again? The liability.
It becomes much clearer. Patient dies, family sues. They demand proof the AI considered a critical drug interaction, saying 94% confidence is, well, useless in court. With FIM, the claim is you could potentially show the court, look, orthogonal dimension 3, that's where we store drug interactions. Positions 7, 23, and 89 were accessed at these precise timestamps verified by MSR counterlogs. And position 7 doesn't just mean something related to blood thinners. It means warfarin interaction because semantic meaning equals the address. It shifts the argument from probability to demonstrable fact.
That's the kind of evidence that could actually stand up in court. Okay, and back to that 40% customer exodus. Is this just about avoiding the bad stuff, or can it actually rebuild that broken trust?
I think it's fundamentally about the trust. Remember, the exodus wasn't just because of the error, it was the inability to explain why. We don't know. This is where the sources talk about a delta DOE measurement that FIM enables. It's the verifiable difference between what the AI was supposed to do, its programming or intent, and what the hardware proves it actually did, the DOE.
Measuring the gap between intent and reality.
Precisely. So instead of we're looking into it, you could potentially say, okay, we see it. At 10.23.45.234, the system skipped relevance check number 47, located at address X. We see it in the hardware logs. It's fixed now. That kind of concrete, verifiable explanation, that's how you potentially rebuild trust. It shows you understand what happened, and you can prove it.
Yeah, that transparency is huge. So this really isn't just defense against fines and lawsuits, so that's obviously critical. It's about building a foundation of trust. It's a competitive advantage. And you mentioned the Brussels effect, EU standards becoming global standards. The first company to successfully use hardware evidence in a major AI lawsuit, that's going to send shockwaves, isn't it?
Absolutely. It would set a powerful precedent. Suddenly, probabilistic explanations might look very weak in comparison. And what I find interesting is how ThetaDriven positions this, according to the sources. They're not claiming they've solved AI or created AGI or anything like that. Their claim is much more grounded. They're saying they can measure what AI does at a fundamental hardware level. They're not adding complexity on top. They're actually removing the translation layers to get to that hardware truth. It's quite an elegant framing.
And it's not just theory, right? You mentioned Intent Guard.
Yeah, the sources mentioned their open source tool, Intent Guard, is apparently operational today, working on actual code repositories. And critically, it uses standard Intel and AMD MSR counters. It's not relying on some secret proprietary chip.
So it uses the hardware already in our machines. That adds credibility. It's not vaporware.
It suggests a level of practical application, yes. And it really frames the choice starkly, as one source put it. You either have attribution or have liability.
A middle ground.
Seems like it. When the stakes are high, can you prove what happened? That becomes the question.
So, for everyone listening, you really have to ask yourself, can you truly prove your AI considered all right things? Can you detect when it goes off script? Can you explain its choices with hard evidence to regulators, customers, maybe even a jury? If the answer is no, or even maybe not, then this idea of delta, say, DOE measurement, of hardware-level proof, it might not be something for down the road. The sources suggest it's needed now. So, we've taken quite a journey today, a deep dive into this really intriguing claim that AI accountability might not just be a software problem, but something rooted in physics and hardware. This core idea, semantic, meaning directly equaling a memory address, enabling hardware-verified logs of AI decisions, it feels like it could fundamentally change how we build, how we audit, and ultimately how we trust these powerful AI systems.
It does. And if you connect that to the bigger picture, it really paints a potential future where AI isn't this opaque black box anymore. Instead, it could be transparent, auditable, right down to the silicon. Which leads to a pretty profound question, doesn't it? What actually happens when every single decision an AI makes leaves behind a verifiable, unchangeable hardware trail? What kind of revolution in trust and responsibility could that unlock? Not just for companies, but maybe for society as a whole, as AI touches more and more of our lives.
Indeed. Definitely not just a technical tweak. It feels like a potential game changer for managing risk, meeting regulations, and maybe, just maybe, building real lasting trust in the AI that's reshaping our world. Definitely something to mull over.